Tiffany.
And this is our robotic arm project that moves a water bottle
From one starting position to the finishing position, which is 90 degrees away and 2 inches higher.
Now, what did you learn in this lab?
This project, in addition to Lab 9, helped me understand how the counters and cycles worked when trying to control servos in the robotic arm.
I learned how to put previous designs and designs given to us together to create like a more complex design. I did that before in the previous labs, but this one's on a higher level.
Yeah, and we learned how to use the design that Professor Marpong gave us to start the beginning of our circuit.
With that design, it made the rest of the assignment a lot easier. Okay, so at the top of our design, we have a D-bounce connected to this circuit that outputs a signal that increments from 0 to 4. And it increases once every 50 million cycles, which is 1 second, and it counts up to 4 from 0. And each of these, and the values are to keep track of the stage of the movement of the robot in the entire motion. And since the counter outputs from 0 to 4, we have 4, what do we call it, these logical comparators to 0, 1, 2, 3, and 4, connected to these 5 blocks that each represent a certain position that all the servos on the robotic arm should be at.
So in each block, we have 5 different gates where each gate has a counter that compares to a particular constant, and this constant basically dictates the position of the servo in question. Mm-hmm. So 75,000 cycles is 1.5 milliseconds, which translates to 90 degrees for the servo, and this goes on for each of these gates. And then there's this input, which is what we got from each of these stages. This input basically goes here with this AND gate, and then
it only allows it to go through when the enable is on.
Yep, so each servo gets a particular signal from this stage, and this happens in all 5 of these blocks.
But only one of them should activate at a time.
Yes, and then over here we have 5 different OR gates, which basically combine the signals that come from each stage. So here you can see the signal from each servo 0 going into this OR gate that gives an input to servo 0, and the same thing happens for servo 1, with this servo 2, servo 3, and servo 4.
So these 5 outputs are connected to the actual servos on the robotic arm, where this is 0 representing the base, 1 as the bicep, 2 as the elbow, 3 as the wrist, and 4 as the gripper. And these OR blocks have 6 inputs, 5 from the 5 stages, and 1 from our design from Lab 9, which will allow the user to control the robotic arm and the servos manually by using the switches and the up and down buttons. Okay, so this is our robot, and here I'm pressing the center button. I'm going to attempt this again, see if this works again. Let me move back a little bit.